The McGurk effect is an example of how the brain combines inputs from different modalities to form its perception of a situation. An audio track of a bar sound being spoken repeatedly is presented simultaneously with a video clip of a person mouthing a gar sound repeatedly. We find that with this conflicting visual and audio information, the subject perceives a dar sound being spoken. As soon as the subject closes their eyes, their perception of the sound switches back to the bar sound of the audio track. This can be explained by the combination of audio and visual inputs to produce an optimal estimate of the surroundings. When what we see and what we hear are conflicting, we will tend to perceive some average of the two presented stimuli. If one of the modalities is less reliable than another for detecting a certain stimulus, shown here by the relative variances of two inputs, a weighted average allows the brain to account for this. This is the maximum likelihood estimation model of perception. Continuing with the examples of vision and audition, cases requiring spatial detection are dominated or captured by vision, like the ventriloquist effect, where results show that the perception of an object's location indicated by both sound and a flash is more strongly influenced by the flash than by the sound. By contrast, consider the following example. Subjects are presented with a series of beeps and visual flashes, and are told to count the number of visual flashes that they see. In this first case, it is easy for most subjects to correctly report 4 flashes. However, in this second case, subjects will tend to report seeing 5 flashes when in fact one of the perceived flashes was an unaccompanied beep. This is an example of audition capturing vision. All of these phenomena are demonstrations of how the brain attempts to make as much sense as possible of the stimuli presented in a world full of highly ambiguous information.